Assalamu alaikum. We know electrons revolve around the nucleus in an atom. If we consider a Bohr's atom in which electrons revolve around the nucleus in a circular orbit, then it appears to be similar to a current carrying loop in which the flow of electrons constitute electric current. Here I consider a circular orbit in which electrons flow. In anti-clockwise direction. So this is an example of Bohr's atom. In which electrons move around the nucleus, a positively charged nucleus, in a circular orbit. Right? Here, the distance between the center of the nucleus and the electron gives the radius of the circular path in which electrons move. Then the tangent drawn to this circular orbit provides us the velocity with which electrons move in the circular path. Clear? This is the Bohr's atom in which electrons move in circular path. It is applicable only for hydrogen atom because it carries only one electron revolving around the nucleus. It is similar to a loop that carries current. Well, this is similar to a loop that carries current. The center, this is the radius of the loop, denominator capital R. Now, the electron, me is the mass of the electron. Then the tangent will provide us the velocity. Clear? Now go ahead. We know current I is nothing but rate of flow of charges. So Q upon T gives us the current flowing through a conductor. In our case, the flow of electron constitutes current. So this is replaced with the charge of the electron, which is nothing but minus E. That is written as I equals to minus E upon T. Here capital T is the time taken by electron to complete one revolution around the nucleus. Clear? And here minus sign represents the negative charge of the electron. I take this one as equation number 1. The next, the velocity with which electrons move in a circular orbit is obtained by dividing the displacement covered by the nucleus by the electron around the nucleus with the time. The time is nothing but time period. Here, the displacement covered by the electron around the nucleus is given by the circumference, that is 2 pi r. Time period is t here. So we obtain V equals to 2 pi r upon t. From this, if we cross multiply, if I take a t this side, we will come to denominator. So it appears something like this. T is equal to 2 pi r upon V. I take this as equation number 2, which provides us the time period, expression for time period. Now go ahead. I am going to substitute the equation 2 in 1. Substituting equation number 2 in 1. What is it? If I do so, then I get I equals to minus E upon 2 pi r divided by V. So this can be written as I equals to minus E multiplied with, when I take this term to numerator, I get V upon 2 pi r. This is the equation number 3. Now I have obtained an expression, an alternate expression for current, electric current flowing through the loop. Now I obtained the expression for magnetic dipole moment, which is typical letter mu L, and it's obtained by multiplying the current with the area of the loop. In vector form, it is written as mu L vector equals to IA vector. The A vector is area vector. The magnitude is the written like this, I into E, the magnitude. Magnitude of magnetic dipole moment. Okay, now I go ahead. I know the value of I. I take this on equation number 4. I substitute the equation 3 in 4. Three in 4. So what I'll get if I do so? You see, here mu L becomes equal to, value of I is minus EV upon 2 pi r, and A is the area of the circular loop in which electrons move. So area of the circle is given as pi r square. Let me write it down here. So in the place of A, I write pi r square. Fine. Here similar terms get cancelled. Pi get cancelled, and similarly r and r get cancelled. So what we obtain is this. Mu L is equal to minus E V r upon 2. This is the expression for magnetic dipole moment of electron. Here V is the velocity with which electrons move, r is the radius of the path in which electrons are revolving around the nucleus in an atom. Now take this one as equation number 4. Now I will write the expression for angular momentum. Angular momentum is represented by letter L, which is the product of mass, velocity and radius. Fine. I take this as equation number 5. Now I divide 4 and 5. 4 is divided by 5 to get the ratio between these two. So what do I obtain is this. Mu L upon L equals to, what is the value of mu L? It is minus EV capital R divided by 2. The whole term is divided by mvr, which stands for angular momentum. Okay, so this can be written as mu L upon L equals to minus EVR divided by 2. When I take this term, so I get this 1 upon mvr. This is how we can write it. Now similar terms get cancelled. V and V get cancelled. Similarly R and R also get cancelled. What do I obtain here now is nothing but this. Mu L upon L is equal to minus E upon 2 minus E upon 2m. This is the ratio of magnetic dipole moment and the angular momentum of electron. Now here, these two are vector quantities. So in vector form, they are represented this way: L vector upon L vector equals to minus E upon 2m. Here minus sign represents that the dipole moment and the angular momentum acts opposite to each other. What I show you here. See, this is the direction of angular momentum, which acts upward, whereas magnetic dipole moment acts in the downward direction. This is the angular dipole. This is the angular momentum. Dipole moment, which acts in the downward direction. So act opposite to each other. To represent that, we have a minus in here. So in magnitude, this can be written as magnitude. The above expression can be represented as mu L upon L is equal to E upon 2m. Here you have to write a minus sign. While we represent this one in magnitude. Right? So this ratio is also referred as gyromagnetic ratio. Gyromagnetic ratio. It relates the magnetic dipole moment with the angular momentum. Okay. And what is E here? E is the charge of the electron and M is the mass of electron. We know the value of these two. Let me substitute and give the value of gyromagnetic ratio. Mu L upon L. The charge of the electron is 1.6 into 10 power minus 19 Coulomb divided by 2 multiplied with mass of the electron. Mass of the electron is 9.1. 1 into 10 power minus 31 kilogram. This is the mass of electron. Clear? Now if we divide this, the value of gyromagnetic ratio, that is mu L upon L, is found to be equal to 8.78 10 power 10. 8.78 10 power 10 Coulomb per kilogram. Coulomb per kilogram. This is the value of gyromagnetic ratio. I box this for better visibility. Understand? Now we'll go ahead. Now here I have considered a Bohr's atom. According to Bohr's quantization rule, L value, angular momentum L is quantized. That means L is equal to NH bar. Here we know here I write it here. H bar is nothing but H upon 2 pi. H upon 2 pi. So in that way, this can be written as L equals to NH upon 2 pi. Here N is the natural number. It can be 1, 2, 3, it goes like that. And H is the Planck's constant, whose value is 6.63 into 10 power minus 34 joule second. This is the Planck's constant. Now if you substitute this, if you substitute the value of H here, then what do we get is nothing but this. Here, there is M V R equals to NH upon 2 pi. Alright. Or if you use this one here, this equation, what do we obtain? Is nothing but answer. This is not required here. Just diagram this. I'm going to substitute the value of L here in the above equation. So what I'll get here, we can write R. Else this can be substituted here. It is better to substitute this one in this equation. I name this equation as equation number 6, and this is taken as equation number 7. Now I substitute the equation 7 in 6. 7 in 6. If I do so, what I get? I get this. Mu L upon L equals to E upon 2M. So mu L is found to be equal to E upon 2M multiplied with the L. What is the value of L? Let me substitute one here. E upon 2M. L is NH upon 2 pi. So, alas, we get mu L value to be equal to, this is obtained from here, to be equal to the charge of the electron is 1.6 10 power minus 19 Coulomb divided by 2, which is multiplied with mass of the electron. M is the mass of the electron. This is the 9.11 into 10 power minus 34 kilogram. This is the 31. I'm sorry, it's given here. Then here n is nothing but the natural number. So I take it as such. It is taken as such. H is Planck's constant, 6.63 into 10 power minus 34 divided by 2 multiplied with the pi, which is 3.14. So if you multiply all these things, you will get the value of mu L. So we go to here, we have n. N is written as such. Then remaining term on multiplication obtained to be equal to 9.27 into 10 power minus 24 ampere ampere meter square. This is the final expression of dipole moment. This provides us magnetic dipole moment of electron revolving around the nucleus in an atom. Right. So if I take the value of n, here I told you n is nothing but natural number, 1, 2, 3, it goes like that. If I take n to be equal to 1, then mu L value will get a minimum value for a mu L. The minimum value for obtained for mu L is taken as the mu B, which is equal to 9.27 into 10 power minus 24 ampere meter square. Here mu B is referred as Bohr magneton, okay, which relates magnetic moment and angular momentum. I hope the video is useful. If you have any kind of doubt related to the topic, can you put your question in the comment section. Thanks for watching.